Good morning. I want to talk about the underlying infrastructure of Web3. So I'm Jiannong from Hong Kong Polytechnic University. Everyone knows about the Web3, and everyone knows that the Web3 actually is a decentralization of next generation web technology applications and the services. And the main point behind the Web3 is decentralization and also permissionless and trustless. So trustless means what? That everyone actually can be participating without an intermediate, without a central authentication. And also we need the underlying mechanism supported, and everyone knows now this is the blockchain. So blockchain actually provides the authentication and also the security, privacy preserving, and also all the actually trust as the mechanisms. But if you look at all the application we have been talking about the Web3, everyone was about the DeFi and also nowadays outsource the AI and all the different kind of applications. But people probably also need to think about, in order to support this kind of distributed applications, what will be the underlying infrastructure? I think that's a Vitalik talk about all the safety, efficiency. What actually rely on is not only the protocol level, but the underlying infrastructure level. And actually, what are the underlying infrastructures of Web3? And everyone knows Web3 is data. Data is a key value. And then last year, actually, I talked about the underlying infrastructure. I focused on the data infrastructure. So we did a decentralized data infrastructure. Think about in the future Web3, not like today's Web2. Our data actually are all stored, managed, and actually transmitted, and all the value created actually are also charged now, actually, or the incentive not going to us. It's maintained by a centralized platform. But how about for the future Web3? All the data belong to us. We actually have a saying, well, we want to store the data, what we want to do with the data. It's about what are the data. Data is not only contents we created, data is also our digital identity. Data actually are all the contents actually we created, right? So last year, if you look at the decentralized data infrastructure, we also have different layers. On the bottom layer, just like Vitalik just talk about the P2P networking. So we need to actually decentralize the P2P networking for storing our data. And then the data actually includes the text, video, avatars, IoT data, all kinds of things you can think of. And then all the data actually can be distributed, stored, like today's, right? We have, PDF, we have also the fine coins. They help us to store the data in a decentralized databases. But most of today's data are stored in a centralized cloud, in centralized databases. So in order to implement or realize the value, we need actually a blockchain. So you can see on top of decentralized data storage, we need a blockchain to help us to actually store the important properties of the data, transactions on the data, values created on the data, sharing of the data must also be stored on the blockchain. And then you have the services actually built on top of this infrastructure. And then you can talk about different kind of Web3 applications. So you can see this is quite a complicated infrastructure for the data. But data is not only one decentralized infrastructure. Today, I will talk about actually, the next one is, sorry. Yeah. Yeah, so today I will talk about actually in addition to the data infrastructure, we need also computing infrastructure. And what's the computing infrastructure? You will think about that all the Web3 processing workloads need to have some support for the computing power. And also, all the blockchain networks need to be supported by the computing infrastructure. It can be a networking, distributed systems, or at least you need a huge processing power. But if you look at it today, most of we so-called decentralized or distributed blockchain systems, they are hosted by a centralized cloud, right? Just like Ethernet. Ethernet nodes, if you look at it, more than 50% are hosted by centralized cloud. And most of them are hosted by Amazon, Google, cloud, all those things. And if you look at also the decentralized IPFS, the DH table, and mostly also hosted by the centralized cloud. And non-cloud takes only a very small part of it. So everyone talk about decentralization, but still today, we are not reaching to decentralization yet. We still actually rely on centralized platform to help us to manage our data, to also do the central processing. So what actually will be needed is we so-called, everyone probably heard about this DPIN, decentralized physical infrastructure networks, and they have been there actually over the past years, and suddenly last year they become very, very hot. And you can see the basic idea is you have all the actually Web3 applications that need many of the processing power but on the different devices, but the device owners actually are decentralized. They actually will be offer their services, their computing power to the distributed applications, but then the computing resource share need to be incentivized, need to be acknowledged, so you need the blockchain incentives. So what is a DP? DP is decentralized physical computing infrastructures resources that managed or incentivized by the blockchains. And you can see there are many actually different kind of projects already. I will share with you in the next slide. And the decentralized resources can be just like CPU, GPUs owned by distributed users. They can also be the physical infrastructures like transportations, like the energy networks, and the computer networks owned by distributed users. So they actually, all the resources can be shared actually through the DPIN blockchain incentives. So sorry. So I'll talk about some of the DPIN projects. Probably people have heard about this. You heard about this decentralized storage, and you see the IPFS, Filecoin, SIA. They are already been there. They have checked a lot of applications already. They basically offer you decentralized storage infrastructures. And then you see actually CPU, GPU power, the IO.NET, Render, and SIDA. They actually try to assemble different geographically distributed computing resources, and then connect them and then offer them as a computing power to the application providers. And I also talk about application specific like energy networks, transportation compute networks. But there are many actually challenging issues today for those existing DPIN projects. I think most of this actually, the DPIN infrastructures are now well structured. They have very good concepts, and they still actually rely on the three fundamental pillars of the DPIN, which is the blockchain consensus for secure task execution, and also efficient resource abstraction, and the decentralized large-scale physical infrastructure. Each of this actually can see have many different kind of challenges. For example, for the blockchain consensus, and used for incentives for authentication of computation and resource sharing, but they can be compromised by any of this dishonest device owners. And for the resource abstraction and management, so far we don't see efficient and management and sharing of resources, and also discovery of resources whenever you have application coming, and how can you actually also show the contributors have done the computation and resources. And for large-scale physical infrastructure still, it's not actually very much available. You can find available resources whenever you have applications with the scenarios. For example, the Otto lab provides valuable decentralized AI computing power, but still suffer from poor connectivity and also performance and lack of the resource consensus. So what I want to talk about from a different angle to look at the decentralized computing power, and this is edge computing. Edge computing has been there in the past 10 years, and you can see the basic idea is that try to overcome the limitations of a centralized cloud. So if you actually collect all the data, send the data to the centralized cloud, and then you need a lot of bandwidth, you need a long processing delay, and then also the data privacy and also security will be compromised. So what's actually is edge computing? And push the data and push the computing resources and storage resources to the edge of the network, closer to the end users, and then you have the computation performed by distributed edge loads. Edge loads can be anything, like base stations, access point, roadside units, or even the vehicles, the cars and robots, etc. And this actually has an advantage that decentralize the computing power, decentralized resources. This is in line towards the idea and the concept of Web3. Okay, but originally edge computing actually developed from a different, path, but now you can see the convergence of edge computing towards the Web3. And if you Google, you find a lot of articles, a lot of research on actually pushing edge computing for the Web3 decentralized resources. Now, actually, we have been working on edge computing over the past 10 years. And from very beginning, we called edge computing is just a single edge load. So today, I will call it edge load computing. The basic idea is that a single edge load already equipped with powerful AR models now. And then you can actually emphasize edge AI, we call it edge AI. So AI models deployed on a single edge load to do many of the very interesting and very challenging applications. For example, you can detect the fake of wine. You can detect the food safety simply by embedding your edge AI models into your mobile phone or into the edge nodes. Or you can embed your edge AI and actually into the robot. So edge AI robot will be the future development or directions of the edge computing. But today I'll just talk about the single edge node. We call it edge node computing. How about we actually connect multiple edge nodes, and then we have a larger pool of resources that can be used for supporting large-scale applications. So this is called edge network computing. And network computing relies on a particular very important function is called task partitioning or task scheduling. So you have a large-scale applications like today, if you want to do AI model or AI large language model inference, and you need to divide this large language model into small tasks, and then you deploy it into distributed edge network nodes. But still, you can see people try to connect edge nodes to form a distributed network infrastructure. And then further to this, actually, is what we call collaborative edge computing. And last year, we did a project actually, and by multiple universities in Hong Kong, and actually we obtained a large grant, research grant, to develop a city-scale edge network. And those edge nodes in the network actually are not isolated. They actually pool their resources together, they share resources, and they collaborate to perform computations together. And that's why we call it collaborative edge computing. So if you look at, actually, we have not only single individual edge nodes, we have edge sublets. And the edge sublets actually can interconnect into a large scale, city scale, we say cover the whole Hong Kong edge network. And then on top of this, they can provide building AI services. And whenever a user connects to a single edge node in the network, immediately it can enjoy the computation power, they can enjoy the AI model services built into the network. So this is the original idea, so we can support much larger scale advanced applications like ChatGPT large language models, like the Industry 4.0, smart city, metaverse, and also autonomous driving transportation applications like this. Now, when we look at this and in the direction of Web3 decentralization, actually we can put another keyword in front of this, and we call this called decentralized collaborative edge computing. Now, what's the basic idea? The sublet of edge nodes, they may come from different stakeholders, not necessarily constructed, built by a single manufacturer or single service provider. So you can have a sub-network of edge network, offered by Huawei, another one offered by Alibaba, another offered by Google even. But then they actually can be interconnected into a decentralized network through the protocols. The incentive protocols actually encourage the different network to join this larger network. Okay, and then different sub-network can connect to different cloud providers. So in that way, all the cloud centers and services will be actually seamlessly connected through the sublets. And on top of this architecture, we actually have this is called framework to supporting this decentralized and also the collaborative network. Now, on the top level, there will be heterogeneous edge nodes, and from probably different stakeholders, decentralized or distributed in different locations in the city or even in the whole world. Okay, if we really talk about sharing of resources through large network. And then how can we build such a decentralized networking? And that actually in the incentive for discovering resources and then connecting to the network, offering the resources for sharing, and then you have to also provide incentives to those resource shares. And then on top of the physical infrastructure, this is, it's not enough. You need to build the resource management layer. You need to abstract resources. For example, if you have a large language model or AI models, how can you measure the computing power needed? How can you know one particular edge node or a decentralized edge node will be able to provide a service? You need the resource abstraction. You need to do the profiling of the computation, the performance of each of the edge network, edge node, and then you manage it through what? Through the DHT, a decentralized data structure connecting our resources. You can quickly discover and search. And then on top of the shared resources, when you have a large application coming, and then you need to have a very powerful decentralized task scheduler. You decompose your large network into small tasks and you distribute it to the different networks for execution. And then in that way, you can provide AI as a service. You can provide any computation as a service. So that acts as a basic idea. And underlying with this decentralized collaborative network is still the blockchain. So we call this blockchain for the edge computing. Actually, many research about it doing this. Edge blockchain for decentralized collaborative edge, and it's many different kinds of functions you can look at of this. For example, you need a data resource network status packed into the blockchain. You need incentive mechanism for the node to share the data, share resource, and also share the computation power. Also, you need the blockchain to provide a consensus who have contributed, who actually performed the computation, who actually shared the data, the contents, and those actually all need underlying a blockchain. So I'll just give examples about what we have done, and on top of such decentralized collaborative edge. A particular one is a large language model. So far, everyone knows LLM is very popular, but most of the LLM actually built on the central cloud, right? Data center. Need a lot of resources. So it's not available to many of the users. Also, you need a long delay and the network bandwidth, etc. And then people think about localized LLM. We call it local AI. But local AI needs your optimization. You compress the model, you trim, and also you actually reduce the model into small model. But then the performance, the accuracy will be affected. So how about actually we still try to inference the original large language model, but based on a large number of shared edge nodes, not a single one. So recently, actually, we have implemented such inference of a very large language model, Llama 2, and the performance is very much comparable with a centralized IIM. But actually, the computation is done on a decentralized node. Another example I want to share with you, in the future, everyone talk about the blockchain, or talk about the metaverse, virtual reality, but that actually need to map our physical environments into the digital cyberspace. So for example, everyone sitting here, I want to build a metaverse with all of you. I need to capture real-time status and then reflect them, map them into the metaverse. That can also be done relying on decentralized power of the edge nodes. So we can have edge node deployed in different places, connect with the camera sensor and actually sensing the physical environment, and then map the real environment into the metaverse. This can also be a very powerful application of the future Web 3. So I'll just stop here. So that's actually want to share with you that the Web 3 need the underlying decentralized infrastructure support, and the edge computing is a very promising approach to achieve this. Thank you very much.